Okay.
I think.
So we start.
Wait, I think not everyone is watching stream. Guys, find Sabah and click on watch stream, and you should see it. Okay, 13 people watching. There's still like 16. Okay, like 4 people, and then we start. Okay, let's start.
All right. We are going to attempt unique paths. So this LeetCode is about a grid. So we have a robot in a grid of MXN. This robot is initially located at the top left corner, so 0, 0. And the robot tries to move to the bottom right, which is grid M and X, or M minus 1 and minus 1. And the robot can only move either down or right. So the robot tries to move to this point in the grid, only moving right or only moving down. Given the two integers m and n, return the number of possible unique paths that the robot can take to reach the bottom right corner. The test cases are generated, so the answer would be less than or equal to 2. Okay, so basically, we have a robot at the top left, and we have a finish cell in the bottom right. This robot can only move right and down, and we need to calculate the number of unique paths that this robot can take to reach this cell. Let's try to draw this grid. So let's take a smaller grid. Let's take this example of m equals 3 and n equals 2 to get the output of 3. So in this case, we have, and we have our robot is here, and we have a finish line here. Let's give it a brown. All right, now our goal is to count how many paths this robot can take, how many unique paths it can take to reach this cell right here. So intuitively, you would say this is the first one. Let's use this. Okay, this is the first path. It can go forward once or right once and then down twice. We can go down once, right once, and then down once again. Or we can go down twice and then right once. Now, in this case, we have 3 unique paths, right? And this is the answer that they've given. So from the top left corner, there are a total of 3 ways to reach the bottom left corner. So right, down, 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 right, and down, right, down. Is it clear enough?
Can they go like diagonal? What's it called?
No. It can either go right and down. It cannot go diagonal. It cannot go back to the left. It cannot go on top. It has 2 ways of moving.
Do we need like to return the number, like the shortest,
The
or like
number, no, not shortest, just the number of possible paths
okay
it can take.
3. Okay.
So if we had like an extra, like one here, for example, then our finish line is going to be here instead. And we can continue. For example, we have, then we would have this as a path, and then we would also have this as a path, this as a path. Any possible path that only includes moving right and down is considered a path. This is a path. Is it clear?
Yeah. Who have a question? Who didn't understand the problem yet? Console log, by the way, you had like a music in background, so I mute you temporarily. Just let me know when you mute your mic and you will unmute. I think everyone understand. Did you guys?
All right.
Okay, please, sorry, what I don't understand is, like, if it moves from the point it is to the second point on the right, if it moves one step right, one step
Yeah.
down, one step right, and one step down.
This one, right?
Okay, I mean, no, put the third grade, please.
Okay. Yes.
Okay, so if it moves one step to the right,
All right.
another step to the left, to another step to downward,
Right and down.
down, right again, and down. Can it go like that?
You're moving right and down, and it is
Yeah.
allowed. Yes.
Okay, so another question. If it goes down,
Yes.
if it goes down and right, no, from the first,
So
it
you
goes
mean like this?
down, right, it goes right, and goes down, and goes right again. Is that a unique path?
Yes.
Okay, so I'm now it down and goes right again, like right twice before going down. Would that still be a different path from? No, I mean
It's cutting. I'm not sure.
it goes down. It goes down.
I mean like this?
Yes, is that a unique path also?
Yes, it is a unique path because the ones that we talked about have different cells that they're visiting.
Okay.
It
Okay.
doesn't mean it doesn't matter if they overlap, right? Doesn't mean if they overlap as long as they don't visit the same cells.
Okay.
But they can't like overlap on the unique, like let's say the overlap on all the, or like duplicates. We can't have like duplicates routes, yeah.
Well, of course, because say this is a route, you can't just tell again that this is again a route. No, it should be visiting a different cell to reach the finish line.
Okay, if we have like two colon, I think we still missing one unique path there, right? If you go right, you go down one time, and you go left.
You cannot go left.
Okay.
It can only move either down or right at
Okay.
any point of time.
Okay, I missed that.
This is the constraint.
Okay.
That you
Move
can
down,
only go right
move
and
down,
down,
right.
right and down. Or either right and down or right.
Okay, cool.
Is it clear?
I think it's clear for me. What about you guys? Who have any question? It's okay if you wanna like if you come late, you wanna like repeat or something. We can repeat. Like the link of the LeetCode also in the chat if you wanna like take a look. I guess we continue.
All right. Does anybody see any way of solving this? So, yes.
Okay, so maybe we can. So we need to somehow to track each path, right? So
Yes.
so maybe
Have a starting point.
Yeah. So
you can start from here.
So do we like save coordination x and the grid, or like x and y maybe, and like, and so maybe we go no idea yet.
That sounds like a BFS. saving the coordinates in a queue.
It does, yeah. But like, how you gonna know if that spot already exists? Or like, if you're like going through the same path as did you go before? So you need some way
Because
to like,
you already have a starting point. Yes?
Can I?
yeah, go ahead,
So
please.
could like put maybe each cell in a list, and then either compare it somehow, like making it into a string, or to compare if it's the same as a different one, or something like that.
I'm not sure I heard you. Can you like maybe speak up, please?
Okay, I'll try again. Is it fine?
Okay, go on.
Can you hear clearly now?
Yes, just go on.
So like if we put it inside a list, each cell's name, like we give their name, 1A or something, and you put those in a list, and then you can either make it into a string at the end and compare the two together and see if they're the same. Because if each cell was visited, then it would have the same combination of things. How about that?
So you mean of putting the coordinates in a list and then comparing the lists at the end to check whether they're the same or not?
Yeah,
Right?
that's the idea.
Okay. We can try that.
Right, can you explain her suggestion? I didn't.
So I believe she said that we go through the paths and we save them in a list. And then at the end of the whatever loop we had, then we compare the lists and I guess weed out the ones that are the same.
Oh, okay, I got.
But I guess that would take too much time to, I guess, first of all, visit the duplicate like paths, and then have to maybe like put them in a set to get unique ones. But I believe that might take too long.
Yeah, but you have a good idea, I think. A good idea to start with.
Okay.
What is there like another? Is
I want to explore the BFS method.
okay, how will that work?
So we have a starting point, right? This is too
but the starting point gonna be like it's gonna be shared between all the unique paths, right?
Exactly, yes. And this starting point is the same across all grids. So at least we have one static thing, is that we're starting from here, right? So we can start all the paths from 0, 0, right? And then we can go right and down. We know that. We cannot go back, we cannot go up. We can go right and down. So I believe that each cell will explore its left would explore its left neighbor and its, I guess, down neighbor. But you cannot go up. So I believe you cannot revisit cells that are up or left. So you go down, and then this one again explores its right and down. And again, this one will explore its right and down. Okay, this is too much. Okay. So we have a start here. This start is we know is a start. So this start is gonna explore left, it's gonna explore down. This cell again is gonna explore its left, its right, and its down cell. This cell is going to explore its right, it's down. This cell is going to explore its right, it's down. Again, right, but no down. No right, but down, and then right. And this way you can visit the whole grid while just, I believe this one also explores this down. So this way you can visit the whole grid while just going right and down, right and down. Using BFS.
Okay, I can see it now.
We've done many
Yeah.
like these like variations of this.
Okay,
But
who doesn't
yes.
see this one? If someone still didn't get the, you can like ask. Maybe we can explain it more, or maybe it's gonna get clear with moving forward. Okay, I guess we continue.
All right. Let's see. We can start with the BFS structure of starting the queue, right? Starting it with an initial cell of 0, 0, right? We fill this queue with an initial. It's going to be a list of this whatever array or tuple we have. And then we're going to have a while loop. While the queue is still full, it's going to gather the two x and y's of this. So the first one is going to be 0, 0. We dequeue or we pop left, right? And then with this x and y, we explore the right, we explore the bottom. So explore right, and then explore bottom. But there still is the issue of how do you keep track of the paths? Do you count as you go right or as you go down? Because this is one singular path. You cannot count anything that like branches. Right. So we need to find a way to count the number of these lines that we have. Yeah. There is one method that is you count how many have reached the end of the grid. You count how many paths cannot branch out anymore, cannot go left or cannot go right or down. So how many branches reach this point, right? So you explore right, you explore the bottom, but if you cannot do any of this, that means you have reached the finish line. And then that's when you count it. That is one way.
Wait, I think this.
Okay, so we have a path, right? Let's make it right. A path, it goes right, down, down. And now here, it cannot go right, it cannot go down. It cannot go anymore. This is the end of its like journey. That's when you count it. That's when you say, okay, this is the end, and you count this path. Now this path again, it can go down, it can go right, it can go down, it can go right, and now it cannot move anymore.
Okay,
and that's when you count it.
Because of the how BFS work, it will never go towards the same path again. Well,
Technically, yeah.
Because every time it's gonna start from different point. Because what if it's somehow we have the same path again? Then we're gonna count it twice. But I think because of
technically have a choice, yeah.
Twice, yeah. Because I think how BFS like work.
Because anytime it can branch out, that's a new possibility, right? And so if you go right, down and right are two different possibilities. And these cannot overlap. Those are two different cells that it's visiting. So in principle, that's a unique path. There is no other path that would get it to this point that would follow this one, right? You cannot go to this cell from this path except on this path, right? There's no other place in this grid.
Okay. Yeah, I see it.
Awesome.
So you are moving forward, and you are like, you can't have duplicate paths. It's
Go
cool.
back. Yeah.
Nice.
Yeah. Now, this method is not only too slow, but it takes a lot of resources because you're basically doubling the number of cells, almost all of the cells. In this
I'm gonna see
queue,
maybe.
you're gonna hold almost double of the cells. At some point, LeetCodes gives you like too much, I believe, memory. You've taken too much memory. So this BFS, the plain old BFS, is not enough to solve this problem. And the solution I found is that you can use memoization or caching. So you store the values of the paths of each cell. Let's explain this in a very easy way. Not sure how quickly I can clear this. Okay, you know what? Oh. Okay. Instead of keeping just the coordinates in the queue, you can keep the number of unique paths that lead up to a certain cell. So for example, we have this cell right here. Right, let's start with the 0. How many unique paths does it need, or does this robot can possibly do to get to this cell? So you get this one and you get this one, right? So this cell will hold the value of 2. That means that this cell has 2 paths, has 2 unique paths that would allow the robots to arrive to it from the beginning, right? So now it is easier to know the value of this one based on the 2 I guess cells on top and on the left. You can now know that the value of this cell is this one plus this one. Does it make sense? So let's start from the very beginning. We can start with this as like our first path. Our first path starts from this. Now this cell is this first path that is gonna be, I guess, transferred to it. It's gonna tell, this first cell is gonna tell it like, I have 1 path leading up to my cell. It's the same path that's gonna be leading to your cell, right? Because this 1 path that starts from here also goes through here. Oh boy. Also goes through here. And that's, my God. And that's the same thing for this one, right? It is 1 path that also goes down here. So this cell is gonna hold the value of 1. This cell is also gonna hold the value as 1 of 1 because it's the same path that goes here and the same path that goes here. All right. Now let's get to this one. This cell is gonna tell it there is 1 path from the starting of this grid that can lead up to my cell, right? So I'm gonna transfer you that 1 path. I'm gonna extend it to you, right? So this 1 path that goes from here to here is gonna go down. That is still 1 path, right? So it gives it the 1. It tells it at least 1 path leads up to you. This cell also tells it, yeah, I have the same thing. There's 1 path from the starting line, goes down, and then it goes right. Now this cell can receive 2 paths, one from above, one from the right. And now this cell becomes 2. There are 2 paths that lead up to this 1 cell. And we can keep going. We can say now this 1 path can keep going. This 1 path can keep going to this one, right? This cell now receives 1 path. Is gonna give the same to its neighbor on the bottom. is going to tell it I have one consecutive path from the beginning to your cell. So I'm going to give you 1. This cell tells it I have 2 paths coming from the very beginning. So we add these 2 paths to this new 3rd path that we have from above. So this cell can hold 3. And then we can keep going down and then until you have at the end. So if we only had these 3 by 2, then the last cell, this one, the grid n-1 is gonna have the answer, the unique paths of the whole grid, because it's gonna be the last point that these paths can reach.
That's actually
Does
awesome.
it make sense?
Oh,
Does it make sense?
I think it
It makes
does.
perfect sense. Yeah.
Who have any question?
So
Please
ba-
don't be shy.
So basically, what I understood, Sabah, is that we're adding up all the possible paths from the top or left cells, like adjacent cells, and eventually they're all gonna be added up to the bottom right cell. So we're gonna have like all possible paths, like a number added up at the bottom right. Is that right?
Exactly. You're gonna add up the top and left to the cell, and each cell is gonna combine the paths of the value of it, like neighbor on top and neighbor on left.
Oh, okay, I got it. That's actually really, really smart. Nice.
It's called, I believe, dynamic programming, DP. So
Okay.
basically, I guess you can loop through the grid and then add it. But I ended up explaining the different solution that I intended to explain. The one I intended to explain was the memorization of this one. But I guess we can get back to it later, I guess. But this one, basically, you just go through in a loop, in a nested loop, right? So you loop through this, you loop through this, and then you go into each cell, and then you keep adding up. And it is very simple to write, but not that quick, surprisingly. All right. So you start by making up a grid, right? So the grid is gonna be, I guess, initialized to 0. And then you start from this one, and the rest is 0, right? This one is gonna be your first initial path, so it's gonna be 1. And then you can start from here and keep going, left and right, left and right. So your grid, so initialize a grid to 0, and then I guess the grid is gonna be equal to 1. And then you loop through X, loop through Y, and now you keep going. So in my XY, so a grid of XY is gonna be equal to the value on top plus
What's the value on left?
value on the left, exactly.
Yes.
And then, of course, we have to skip this one because, I mean, I guess we don't need to skip it since it's going to be 0, 0. So if it is on top, then it's going to be 0. If it's on the left here and you cannot reach it, it's out of limit, then it's going to be 0. So you can, I guess, value on top is going to be the value on top if the x is bigger than 0. So if x is bigger or equal to 0, x is bigger or equal to 0, else is going to be a 0. And the same thing for the value on the left is going to be equal to the value on the left if y is bigger or equal to 0. So if we are not outside of the grid. Oh, it's not. it's x minus 1 because we're going on top. So x minus 1 or y minus 1. So in this case, y minus 1. Else, it's going to be easier.
That I got it only once.
You have code 7. I think you have it. Okay, fine. You can continue.
Okay. And in this case, you just return the last cell in your grid. So it's going to be grid minus 1, minus 1. All right? Is it clear?
Kachi, I asked you to get me water. I'm still waiting for that water. Maybe it's when I sleep, I bring the water.
I'm not sure if you're talking to us. Onion-chi, I think your mic is open by mistake. Okay, I will just mute her. Okay, continue. And someone
Okay,
bring
is
her
this
water,
clear?
please.
Is this clear before we actually translate it to code?
Yeah, it's perfectly clear for me. Thanks, Sabah.
I think one thing is maybe clear. I'm confused how the grid X when you do value on top plus value on left. Can you like repeat that line? Why?
All right. So in this case, right, you have one unique path going from the top that is carried by the cell on top, and it has the value of 1. So this cell has one unique path leading up to it, and this cell has one unique path leading up to it, right? So these two paths, you add them up to return 2. So this cell has 2 unique paths, one from the left, one from the top.
Okay.
This one has 3 because
Okay, I
you
see.
count these 2 and then the one on top.
Okay, I see. Yeah, top and left because you can only go down and come from the right.
Exactly.
Okay.
All right. We can copy that. And all right, initialize a grid to 0. We can either do it the long way, it's a very quick way. Okay, grid equals, so you have a list. So it's going to be a list of lists, right? So we want to initialize it to 0. So it's going to be 0 times how many, we have m as a y and n as x. So it's going to be n times 0. So it's going to be 1, 2, 3, 4, 5, n times. And a loop that will copy this m amount of times. So for in range m. So this, if we were to, maybe I can comment this out. If we were to run this, it should give us this grid. So it's 7 n's, 7 zeros, and then three lists. So 7 in x and 3 in y. Hope that was clear. And now we initialize the first cell of this grid to 1, and then we loop through the x. So for x in range m, or n, I guess in this case, n, for y in range m. Now, value on top, let's...
I think you've conflicted the axis.
Excuse me?
I think you've conflicted the axis. The outer loop should loop through M.
All right. All right. So the top is going to be the value on top. The value on top is grid of x minus 1. Why? Because on top is going to be y, not x. All right. So the top is going to be y minus 1 only if y minus 1 is bigger or equal to 0. So if this cell exists, as in it's not beyond the limits, then it is grid xy minus 1. Else, we're just going to consider it 0. The value on left is going to be the value on left, which is on the x plate. So it's x minus 1. So I guess I've confused them here. So it's grid of x minus 1, y, only if x minus 1 is bigger or equal to 0, else it is a 0. Now, the current cell is going to take from the top and the left, and it's going to combine them. So it is top plus left, and we return the last element of the grid. See if
Before you run
anything.
this, I think the same thing
Yes.
is happening here again, right?
Yes.
The axis on line 7 and 8, right?
7 and 8.
So the value at the top should be on the row before that particular row, right? At the same index, right?
Yes.
So it should be x minus 1, right?
No. So
for example, you have m in the first example, m is 3 and n is 7, right?
Then y. Right. So on top is going to be on the y. On the left is going to be on the x.
Yes, but you know, m
What?
is the number of rows, right?
M is the number of rows, yes.
Oh, yeah, so you have 3 rows. So the value above you should be the row above you. So if, for example, if you're at index, if you're at m is equal to 1 and n is equal to 1, that is the second column in the second row. You would have to go m at 1, right? At 0. You want to go 1 level above you, right? I don't know.
So you think we're confusing these
Right.
two then?
So if you run this now, you get an index error. If I'm correct, right? You get an out of index error.
Let's do it. Okay, I guess. So, oh yeah, I believe we're overriding this one that we added here. So if x equals 0 and y equals 0, then we should just continue because that makes it a 0.
But Sabah, I guess.
Okay.
Oh, that works. Okay.
That
I
works.
guess what I
So maybe
meant
I was
is that
looking
the grid of x, the top value should be x minus 1 and not the y minus 1 because y represents the horizontal cells. I think that's what he meant.
here.
The horizontal axis and the x represents the vertical.
I guess you could flip them because
I
that
mean,
would be the
it works
same.
because it's the same. Yeah, it works because we're doing both cases anyways. So yeah.
Yeah, if you
Okay, that's true. That's true. Since we are basically doing the same thing on either operation, I guess.
Yeah.
technically go this way, I'm not sure.
Yeah, just
But this one is here and this one is here, it would give you the same answer.
Yeah,
Yeah.
correct.
Right?
Oh, I didn't think of that. Nice.
Okay, but it is very slow.
It is pretty fast. If it beats 40%, that's basically what this is.
No.
Right?
There is.
Yeah, so another thing about LeetCode is the performance metrics aren't reliable. Like, for example, you see that you've gotten a 25% boost by just running it again. So a 30% boost, basically, by running it again with no changes, right? So, yeah, that's... So you don't,
there is a
kind of
faster way, though.
Oh,
I suppose.
there is?
There is a faster way. There is, yes. It's the memoization that I forgot to.
Okay, yeah.
Fine.
You keep track of the values you completed earlier.
It is basically the same concept as this. It's just you're doing it backwards. Instead of being on the cell and taken from the left and on top, you are on the cell and given to the right and bottom. It's the same grid. It is the same concept technically. So in this case, you are.
What do you save in
have
the
your-
memoization? What do you save?
You
Or like-
save. It is the same thing. You save the values of the number of unique paths leading up to a current cell.
Mm,
So each cell holds how many paths it can lead up to
yeah,
it.
yeah.
And it passes that on to the right and to the bottom. So you can do the same thing. A grid initialized to 0, and then you I guess the first one, grid 0 equals to 1, and then you hold that in the queue. You pop X and Y, and when you explore the right, in this case, if the cell is visited, if it is visited, if it already has a value, if it is not 0, then in that case you give it whatever you have. So whatever cell I am, let's say in this case, so let's say in this case I am a 2, right? Or I am in this cell, I guess, and I am in this cell and I know my value, and I'm gonna check my right cell or my bottom cell. In this case, we don't have, I guess, a bottom. Let's just see this 3 by 2. So I am in this cell, I check my right. I check if it already has been visited or not. If it has been visited, then I just give it my value, I add it, right? If it has not been visited, then this cell is brand new. Then I add it to my grid, and then I give it my value. So if we were to, let's just remove all of this. And then all of these, this now holds 0. This holds 0. And this one also holds 0. Right, we're starting from 1. Oh, I guess also these. Now we're starting from 1. 1 is gonna check its right, and it's gonna check its bottom. Right is 0. This cell has never been visited before. So we add it to our queue, and then we pass along our 1. So now in this case, this is 1. And this cell is added to our queue. It also is gonna visit its bottom, and its bottom is 0, so it's also not been visited before. So it's gonna pass on to its 1, and then now this cell is done. It has visited its right neighbor, its bottom neighbor, and it is done. Now we have removed this cell from our queue. We move on to the right. Now this cell is gonna have to visit its right neighbor, its bottom neighbor. Right doesn't exist, so it's bottom. It checks if it exists. If it doesn't, in this case, then it adds this cell to the queue, and then it passes along its 1. So in this case, we have a 1. Now, this cell has finished its job. Now, the next cell is this one. This one visits its right, its bottom. Now, the right has already been visited. So it doesn't add it to the queue, but it also passes along its 1. So in this case, we have a 2. Now this cell has been visited by its top neighbor and its left neighbor. So it's the same concept, just a little bit. And it keeps going. This one visits its left, its right, its bottom. It gives this one a 2. This one visits this and then to this. And at the end, we find a 3 in here, and we return the last grid.
Nice. This is super cool.
So now when we explore our right, we check if cell is visited. So if it is not visited, add to queue. If it is, then if it is visited or not, you just pass along whatever value you have. So you add value to neighbor. And you do the same thing with the right. You check if the cell is visited with the bottom. You shall, if the cell is visited, if it is not, add it to the queue, then you add the value to the neighbor. Is this one clear?
For me, yes. What about you guys? If you have a question, please don't hesitate. You can open mic talk or like in the chat. Think it's clear? We continue.
Okay. Then we can just so we might keep most of this. So we keep the grid initialization. And we keep initializing the first cell to 1. And we initialize our queue. So Q equal DQ. All right. And then we add the first element of our grid. So it's 0, 0. Right. Now we can, I guess, just remove this. All right. Now while the queue is full, you pop the left element of our queue, and then you explore right. Exploring right basically means that you're gonna check if, so I guess right. So if your x is smaller than the limit. So if x plus 1, so if x plus 1 is smaller than our n, because n is on the x, so it's smaller than n. You check if the cell is visited. Checking the cell is visited basically means checking if the cell holds value. So if grid x plus 1, so the neighbor, so if this has value, or if it doesn't have value in this case. So if it doesn't have value, then what's wrong with this? Okay. If it doesn't have value, then you append it. Q dot append x plus 1 y. And then you add the value to the neighbor. So this is the neighbor. It's gonna hold its current value plus the value of the current cell. So grid x, y plus grid of x plus 1y. So it's a plus equal of grid x, y. And it's gonna be, it's gonna be the same thing for the bottom. So you can just copy this one. And in this case, it's gonna be a y if it's smaller than m, and if grid y plus 1, you append y plus 1, and it's y plus 1. I'm not sure why it's showing me the red one. Invalid syntax. Well, I guess if it equals 0. If it equals 0. Is this clear? Is this one clear?
How do we know that the cell is visited?
So
do we check if
we
it's have value
initialize.
0?
Yes, so initialize the whole grid with zeros. If it has been visited, then it already has like
More than
a
0.
value because we exactly. Okay. So if the cell is 0, that it means it's not visited, but I'm not sure. Where is the...
List index out of range. So
Oh,
x
list
plus
index.
1.
X plus 1 is smaller than n. Confused. So x is going to be here, plus 1, and then our n.
Shouldn't it be n minus 1? Or
No,
no?
it is going right and it is going down. So it is a plus 1, plus 1. And this is x, so this is x plus 1.
It should be n minus 1, I think.
Because the last cell is at index 6
It's
and
n
not
minus 1.
7.
But I'm using like strict smaller than.
Oh
Not
yeah, right.
sure minus 1 should do
Yeah,
anything.
you're right.
But...
I think you're right.
It would give the wrong answer.
Which line?
Oh.
Line 9.
So
Okay, if grid x
this
plus 1.
But the grid already...
Interesting.
I don't understand why this should not also work. I officially
they
don't
were
understand.
Oh, oh no.
I cannot explain this. No, sorry. It's just so funny.
They were swapped.
This one is definitely faster. It gave me 90 something earlier.
Yeah,
So
69.
Yeah, so like I said, don't bother about runtime. The statistics on LeetCode are not reliable, right?
I guess.
But like in theory, I think this one is
I'll just
better.
keep it at that. Yes,
Nice.
this one is... The other one was simpler in terms of logic. But yeah,
Nice.
that is all I have today.
Thank you. It was nice to know. I should work on this one because my mind is still trying to catch up. Okay, so second LeetCode is longest palindromic substring. It say give us a string S, return the longest palindromic substring in S. Example, bad or bad. The output should be bad, but explanation ABA is also a valid answer. Example 2, say BBD. So BBB is like the longest palindromic substring. Let's take this to the Excalibur and try to come with solution for it. Is it okay? So what do you guys think? Who didn't understand the problem? So palindrome is like if I have a text, for example, EBC BA, this is palindrome. For example, if I go here to check, it is a palindrome. But if I add if I add, for example, a here, it's false. So it's like a mirror. There is a mirror here. There is a mirror, and this side should be equal to this side. There's also a palindrome if we say A, B, C, C, B, A. This is also a palindrome. So it can be odd and this can be even. So if we did like in the middle, so the middle here gonna be this. So this half is equal this half. Yo, thank you, Mahmoud. Nice to see you. So we are looking, for example, if they give us B, A, the first example they give us. First example, B, A, bet. So this is it have palindrome right here. It have this as a palindrome, right? Because if you split it on A, you have like B, A, B. This is a valid palindrome. But you also have this right here, valid palindrome. But we are not like looking of how many palindrome exist in this string. What they say is like what is the longest palindrome. So this BEB is 3 character, and EBE is also 3 character. So one of them, if we return one of them, then it's valid. So I guess this BEB, the return is the output. And for CBBD, let's see. So this one, these 3 characters are not palindrome. So BPD, this 3 character is not palindrome. So this one is not, but these 2 characters are palindrome. So if we go like, for example, if I write BB, it's true palindrome. If I write B, it's also palindrome. So if we have 1 character, it's palindrome. What that mean? It means that if we have just CBD, what is the longest palindrome? We have here 3 palindrome. This is C alone is palindrome, B alone is palindrome, D alone is palindrome. So we can like return, for example, just C. This is the longest palindrome. Okay, I hope the problem is clear. What do you think, guys? What if it's not clear for you, let me know and we can brainstorm. There is many solutions to go through with this. One of them is like what is called expand from center, I think. Yeah, expand from center. So if we have, if we remove this, so what you do is like gonna loop on each. I guess we don't have any other way, right? Either we need to loop through all the character. So we're gonna loop on this, then we're gonna expand from center, go to the next character, expand from center, go to next character, expand from center, and each time we expand from center we get the largest palindrome. So if I go to B, or like let's say we reach to B right here, and we expand from center. So basically we're gonna fix B, and we're gonna check if left and the right of it are equal. If they are equal, then we add it B, B, and then we say, okay, let's expand more. Then this gonna go to here, this gonna go to here, and then we say, are D and this equal? No. So we understand that this is not palindrome, so we don't include this character and we return the last palindrome we got. So we save this, we save it, we say this, okay, EBE is the longest palindrome. But if we have, like, for example, if we have in the memory, let's say here we will save the longest palindrome, save longest palindrome. So at the beginning this is going to be empty, right? Or maybe we can save just the first character, assuming at the beginning that there is no palindrome, so basically B, the first character, is going to be the first palindrome. So we're going to save it here. Now we save E, A, B, A. Or in the beginning it was just B, right? And we launch this expand from center function on each character. So at the beginning it's going to be like B, and then we launch this expand from center. I'm gonna explain it more. Now when this expand from center return a value which is the biggest palindrome he found from that point of the string, we're gonna compare it to the memory what we already have. We're gonna compare it is longer, right? We're looking for the longer. So to make this bigger, let me maybe move it. So B. So it was B and this return AB. I will say, okay, which one is longer? This one. So I remove this, I save this, right? And remember, we are like looping through each character, right? So the next time when this gonna, by the way, I randomly start from the center on purpose. Let's say now we go to the next character. Okay, let's go. We go to A. Let's do again expand from the center algorithm. And what we're gonna do is we're gonna have like two pointer, one here, and we're gonna see from A character how much we can expand to get the most possible palindrome. So we have D and B. Automatically we return like nothing, right? Because D and B, they are not equal, so it is not a palindrome. So we can return just A, for example, here, and then we can like compare A with the longest palindrome we have already. And
Mansaf,
yes,
I have a question.
yes, please.
What if the palindrome string is an even, like the second example BB, like it only like the palindrome only goes from one side. Like let's suppose it's the CBBD. So while we're at the B, it goes to the right only, and it's still a valid palindrome. We don't have to go for like left and right.
Okay, let's create an example. Give me a word like this. BB.
Like C, yeah, for example, yeah. So if we for example, if we stand like the pointer is at B, and we try like the center expanding from the center method, if we go A and B, they won't be palindrome. But if we go to the right side only, we have BB, which is palindrome. Do you get what I'm saying? Like where the problem could be?
Test. Can you hear me?
Yeah, I can hear you now.
So here, if we say this gonna expand left and right, by the way, it's a good question. It was something that I was gonna mention after, but it's good to talk about it right now, because we have in palindromic we have two cases. We have even and we have odd. So if we go to this, it's gonna say E and B, they are not palindromic, right? EBB, because this one is checking only odd, right? Because ABB is not palindromic, so it's gonna stop, it's gonna return. But what we're gonna do is we're gonna launch two expand from center. One is gonna be going on from odd, and one gonna go from even. So for example, when I'm gonna launch on the first so first expand for the odd, it's gonna go to B, and then it's gonna check this way. It's expand from this. But for the even, we actually go from so we go like this. We start from 2, and then we expand from here. So when I'm actually moving left and right, I am moving. So like in odd, I have 2 pointers pointing to the same character. In even, I have the left and right are pointing to 2 different one, or like the closest one. So when this gonna move to the right and this gonna move to the left, I can see that I got A, B, B, A as a valid palindromic. But because now I'm treating as even, but if the expand odd, it will not catch that, because when he expand, he move. We have 2 pointers on top of each other, so when I move left and right, I am like, okay, this is not palindrome. So we have to have 2 function, one for odd, one for even, because we can't. It's the only way, because we don't know if that word is even or odd. Or because we are looking for substring, right? Because it may be the word even, but the substring that is palindromic is maybe odd inside of it. Or it is odd, but the substring is even inside of it. I hope that's clear.
Yeah, that makes sense. So in the case, like, we're checking for both if it's odd or even. In the case if it's even, we're gonna have 2 pointers point to the center, 2 characters, I mean. And in the case it's odd, we're gonna have just 1 character and expand from that. But if it's an even, we're gonna have 2 characters as the center and then expand from both characters. That makes sense. Yeah, that makes sense.
And basically, by the way, we don't know if it is odd or even. So while we looping through the characters, we're gonna launch on each character to expand, because we don't know. I'm gonna come here, I'm gonna launch 2. Then these 2 gonna reply back, and I will just check the length, which one that have the most length. Is it the odd or even? If it was the odd, I put it here. If it was even, I put it here, because I only care about what's the return of this expand function. And then when I'm gonna go to A again, I will launch 2 on this A. I'm gonna launch 2 expand on it, which one is gonna go like this. It's gonna keep expanding like this, and the even is gonna go like 2 pointer, and they're gonna keep expanding like this. And we're gonna keep doing this until we reach the end. And by the end, we should have in the memory the most longest palindromic we found. We can, if anyone have any question, we can start writing like pseudocode, and then we write code for it. Okay, I think. Okay, let's go with pseudocode first. So pseudocode first, we wanna design the palindromic, or like the expand function. The expand function, we're gonna say, let's say def. Let's say def expand. So this expand, because it's gonna be the same, we will need 2 pointers. So if we are in odd, we're gonna give it the same character. If it was In even, we're gonna give it different character. So left, right. So this is expand. Now, if I am on here, what do I need to check when I give it left and right? So let's say I'm checking this string as odd, so I'm gonna give it 0, 1, 2. So the index of this character, wait, so we have string in S, so we can do like S, and for example 0, 1, 2. Like we can play with the index to like get which character. And so in this right here, it is B. Let's say we are on B, and I'm gonna launch on it the expand function. So I'm gonna give left 0, 1, 2, and the right's gonna give it also 0, 1, 2. So it's like I'm gonna do expand 2, 2. And inside this function, what do I need to check? Because the goal is like to keep moving this, which is normally is two pointer on top of each other. So it's like we are doing like this. And then I'm gonna move right once and left once. And then I need to check, are they equal? Is this equal to this? Or I can even like check if this left and right are equal first. Are they equal? Because because if they're not equal, there is no need to expand. In case of odd or even, because in both even or odd, they should be equal. So here is our first condition to check, if left and right equal. Okay, what else? We don't want to expand until we go outside of the range. So if the left right equal and we don't get out of range. So this is two conditions we have. So we have if left and right equal, and maybe I should write this better way, and the left and the right inside the range. By range I mean the character, the string character, so it not go outside of it. So what we're gonna do if it was equal, which means like this, BB, and inside of the range, what we need to do is we need to move them to check if this to check if this is a valid palindrome. So let's say we move them right here. Okay, how we can do that? Yes, we're gonna do left, move left once, move left to left, one step to left, move left one step to left, and move right one step. Wait, is that correct? Yeah, so left one gonna go back one more left, and the right one gonna go forward to the right. Move right one step right. Okay, now we did that. Here we go. Boom, boom. We move them, and then we have to check. This be gonna be like a loop. So we need to check somehow if these are correct. Now if we do like, and then check if, okay, Cody, nice to see you. check if the string or like the substring is palindrome. Wait, how are we gonna check if it is palindrome? Because we know the B in the middle is palindrome. So the B and A, if they are equal, then it's palindrome. So we can keep the same condition right here, because we have it here, left and the right. No, left and the right equal. Yeah, so we can loop on this. Loop, while loop. While true maybe. Or like, yeah, while we can do while left and right equal, and the left and right inside the range, move this. And it's gonna keep moving until one point either they are not equal or they are outside of range. Then we're gonna return the string, return the substring. So I maybe did go fast on this point. So like we're gonna create a while loop that we're gonna keep looping all the string from this beginning. So first it's gonna check. Really? Test. Okay. Yeah, I'm not sure. Maybe my mic. It's good now, Abdurrahman?
Yeah, it's good
Okay.
now. It was my internet. Sorry about that.
Yeah,
Sorry about that.
No worry. So like we're gonna do while loop. So it's gonna go left. So first it's gonna be like this. It's gonna enter the while. Why? Because the condition left and right equal. Yes, they are equal. And is it left and right inside the range? Yes, they are inside of range. Okay, move them. This is gonna go to the right, this is gonna go to the left, and then it's gonna loop again, right? Because it's a while loop. What is the condition? Left and right are equal. Are they equal? E and B, they are not equal. So it's gonna stop. It's gonna stop, and it's gonna return the latest, or like it's gonna return. What do we need to return here? We're gonna return what? We're gonna return B. We should save the substring and return it. I guess we're gonna. Okay. It's gonna return the left and the right, but we did move left and right to the left, so the value is gonna. The value is gonna change. Okay, why I'm missing something? Left and right. So we're gonna return left and right. But isn't we move left and right? We move them. So it's gonna return E and B. It's gonna return EBB, which is not valid. You only move if they are equal. Oh yeah. So we do we only move when they equal. Okay, let me see. While left and right equal, okay, right here. Move left one step and left. So we don't move them until we check if they're equal. Or, okay, we can do this. Left plus 1 and the right plus 1. Oh, okay, that's smart. Okay, so we move this left and we move this right. But if we loop again and it didn't enter, we're gonna return B, because we're gonna do like this one. So return. What this means is it's gonna return left minus 1, which is B. I'm not sure if it should be right minus 1. I think the here we don't do so if I put 0 1 2 3, if I put 3 it's actually gonna return B, the 2, or I'm dreaming. Think so. We can test it. So S okay, which is what we need, but we need but if we did -1 it's gonna return A. Why is it? Because right is gonna be B, so it's automatically gonna return B. Let's say this is C, right? So if I did the right, it's gonna return C. Okay, let's test this. I'm just I want to understand this. Okay, so let's say S, we have S, this, right? String S, and okay, where is the, and we say string left and right, print S. So left, so let's say left is B, or let's do C here. Okay, C, left is gonna be B, so 0 1 2 3 3, and the right is gonna be 0 1 2 3 4, right? So what this should print? Tell me. If I click run, what does it should print? We are looking for, to make it sure, we are looking for C. Is it? Wait, I'm tripping. E, B, C. Yeah, we're looking for C. Wait, is it? Yeah, the third character. We want to return third character. So this should return C. I think it's gonna return. It's gonna return A or empty, because let's see. Yeah, empty, because it's left is more than right. Or yeah, left is more than right, because left +1. So 3 is character C, and the right is character B, A, C, B. I think this is confusing. Let's do like E, B, C, E, D, F, right? So E, B, C, 3, oh, 0, 1, 2, 3. So 3 is E, and the right is, what the hell I'm doing? So
actually, so
1, 2, 3. Yes.
Actually, they should be like 2 indexes apart. So if you start from C, which is 2, the left should be 1 and the right should be 3. They should be like 2 indifferent. It's gonna return empty either way, but left needs to be, because if you start with an index of 2, right is gonna be 2 + 1, left is gonna be 2 - 1.
Okay, so what we did here is we did left move to the left and the right to the right. So the right was so left and the right were 2, right? A, B, C, 0 1 2. So 2 - 1 is 1, and the right it's gonna be 2 + 1 is 3. So this gonna be, and this gonna be E, right?
Yes, but it's still gonna return an empty string, so.
Okay, we are looking, or it should return C, right? A, B, C. This is what we're looking for. But if I remove this, I think it's return C. Right? So I think because the right is should be okay. If I did left plus 1. What that mean? Left plus 1 is 2, and the right minus 1 is 2. So 2 2, it's gonna be empty. So it needs to be 3. So like in the when you slice in the right, the parts should be always plus 1. It's confusing, but I hope this someone confused. I hope I did confuse you more. Okay, let's go back. Okay, this is very smart. We can do this. Is left plus 1 and the right. So so this gonna give us the character, the middle one. Why we looking for it? Because this one failed. This one failed. We did enter the while loop, and the while loop keep looping. It stop when it fail. Where it fail is either we out of range, right? Or in this case right here, we have E and B, they are not equal. So our palindromic is the recent value, which was when we were here. Now we can like make this example better if we could do even. I think even it will work fine. So even, when we are even, we're gonna launch the same expand, but instead of give it 2 2, we're gonna give it 2 3. We're gonna always add 1 to the right, which mean this gonna start like this. And so someone may ask why you start from middle. This is just a random example, because at the beginning we're gonna start from here. We're gonna keep moving to this character. So to this character, to this character, to this character. And when I am in this character, I launch 2 expand function. One I give it 0 0, one I give it 0 1, because 0 1 is the even version. And then it's gonna return something, both of them. I'm gonna check the length. I'm gonna save the bigger one here. I go again to the next character. I'm gonna launch 2 expand. I go to the next character, which is the example we are working on right now, is when I am on the 3rd character. When I'm gonna launch add, or like add, you see it before. It did stop when A and B different, but when I launch even, it's gonna be like this. Let me remove this distraction. So in even, it's gonna do the same loop. While left and right equal, is they equal? Yes. B and B are equal. Okay, nice. What's second condition? They are inside the range. Yes. Move left 1 step to the left, move right 1 step to the right. Okay, here's the right, move it 1 step, left, move it 1 step. Loop again. Is the condition of the while loop is correct? Let's see. The condition say if left and right equal. Are they equal? Yes. A. Is they are inside the range? Yes. Okay, nice. We're gonna move them again. Move B to the left, or like move the left to left and the right one more to the right. Check again the condition. Left and right equal? No. B and D, they are not equal. Okay, what that mean? That mean the loop it's not gonna enter, it's gonna stop, and then we're gonna execute the last line, which is return this string. Now why we did this slice? Because we don't want to return this whole string, because we know this is not equal, this is not equal. So we only want to slice this part right here, EBBA, which is string left, which is left right here. We can add +1. So left is on the index 0. If we did +1, it's gonna be like here in A. That is good, that's what we want. And then we did the right. Now right is on here, but we don't want to include D. But the way the slicing work in Python is, if you want to get A on the right, you actually do +1. But because we already on +1, because our right is here, so we don't need to do -1 or like right +1. So this is how the expand work, and then we're gonna get this. Now we have expand function, which is work fine, I believe. I hope so, at least. Let's see what we're gonna do with it, because this is just one part of the solution, because we still need to loop on each character and launch this expand function. Okay, so Here we go. Expand is ready. How we gonna need to start, or like, so we say they give us this string. We say we're gonna come here and launch to expand, move here, launch to expand, move here, launch to expand. So it's already a loop. So first of all, before I do everything, I need to loop on each character and launch to expand function. Okay, let's create this loop. How we gonna do it? So I guess we're gonna loop on each character of string. Okay, so this line is gonna create the loop. It's gonna keep looping until the end of the string. Now while I'm inside this loop, what should I do? So we say we're gonna launch two expand functions. So we have left and right. We have even and we have odd. So let's call this add, launch, add, expand, even, launch, even, expand. So basically this is gonna be like example E, right? Because they are odd. So E plus 1. So when I'm gonna go, for example, to B, I'm gonna launch expand. So the add function. Let's do. So expand have 2 pointer, right? We have one right, and we have one left. So when I'm in add, E and E they are equal, right? So E and left and right gonna be on top of each other. That's nice, because when we're gonna move in, we're gonna move like this. Left, move, that is nice. Now the even one, it's gonna be E plus 1, so it's gonna be like this, which is the case when we have even. Then when we're gonna keep moving, we're gonna move like this. Now this expand function is gonna return string. Nice. Now this string, we need to compare which is the bigger one, and then get the bigger one and compare it with this. Or like we can just compare add, see if it is bigger than the save memory, or like the results. Let's say result. At the beginning we say it's gonna be empty, or like we save only the first character, and then if it is bigger we replace it. And then we go to even and see if it is bigger than with the result. If it is bigger, then we replace it. How are we gonna do this? We can like maybe check if length of add is bigger than result, or like if length of add is bigger than results, update results. Then if length of even is bigger than results, update results. So the bigger one is the one that's gonna take over at the end. So this is a loop, right? So this should be here. So this is a loop. It loops through each character. Launch to expand. Go, launch to expand. Go, launch to expand. Go until the end. Then at the result we should have the most bigger substring, or palindrome substring. So after the loop finish, we should return results. Turn results. Okay, I think that will be the pseudocode. We can convert it. Is anyone have question? Let me catch up with you guys. How about launch the even only if the next character is equal? Like, okay, sorry guys, I missed it. Where did he suggest that? the only way it can be even if two characters are successively identical, maybe that should trigger. Oh, okay, that's cool. Yeah, okay, so on even here, only if you mean here, right? So I'm gonna do check if character I and I plus 1 are equal, then maybe like this. Okay, yeah, I think that will help. So like no need to launch. And do we do it also for add if they are not equal? Like if they are not equal, we launch this. Otherwise, we or like if they are equal, we do this. Oh, yeah, you're right. Yeah, sorry. Yeah. Okay, what else? Yeah, it's more efficient. It will return palindrome when it's not. Oh, really? EBC, it will return not only that, but if it is EBC, it will return a palindrome when it's not. Wait, how is that? EBCA. Okay, I guess never mind. I just get it. Okay, cool. Okay, let's see how we can transfer this to code. Okay, I have chat open in my phone, so if you guys said something, I can read it too. So how we can do this? Let's define the function first. So def expand. We're gonna give it left and right. Okay, here is it, expand. Oh, I'm sorry, making you dizzy. So what else? We said while left and right, so it's gonna be while loop. What else? What else? While left and right. So while. Wait, I forget how to write while in Python. So while like this, right? Or do you use? I don't think I do parentheses. So while left and right are equal. So left and right are equal. Okay, so S left, because it is the index, right? So S left and S right. Because what we mean by left and right are equal. We mean like the character of A and B, or like the character, not the index, because we are expanding the index, so it doesn't make sense to be equal. Did you get this one, guys? So we need the character to check if the character is equal. And left and right inside the range. So the range gonna be, let's say the max, or like length of the string of S. We're gonna call len S. So this is the length of S. So we can check if the left is okay, no. So left should be less than 0, or like bigger than or equal 0. Because if it's outside of range, this means the index is more than the range. I'm saying true, or What do you think? Do we do left, right? Left should be bigger than 0 or equal. Bigger or equal. Yes, I think this. And what else? The right. The right should be the bigger than the, or like less than the end character, which we can get it with the length. So right less than the length s. So the length is, if this have 6 character, so this is gonna be 6 character. So the last character have index 5, which mean I don't need to do equal here, right? Because this is gonna give me 6 and they only need 5. So greater or like less is fine. So while in this condition, what we gonna do? Put the check first. What do you mean? Put the check first. Oh, this one? Or you get an error regardless. What check? Left, right? I'm not
So you
following.
check for the validity of the indexes first, then you check the equality. Because the while loop goes in order.
You're right. This is a very good point, yes. Because if they are outside of index, when I'm gonna try ax them here, it's gonna give me index out of range. Yeah. Nice catch. So we said while we doing this, when inside we're gonna move left. So left's gonna be we can do -1, and the right we're gonna do +1. Right? That's this part right here. And okay, and return is there left. Okay, so return is outside of we don't have str, or we have s. So s, string s, left +1, and the right. So this way we have the expand finish. Now we go to the second part, which is loop. We can use for loop and e, and then in range, and we need the range which is gonna loop through on each character. So we have 6, but we need only 5. So I always forget this. If you did the range 6, is that mean it's gonna count from 0 to 5? Because that's what we want. So length of s, it's gonna be, do I keep it 6 like this, or I do -1?
No, just as is. The length s doesn't count the last thing, so it's from 0 to 5.
Okay. Is that what we want? Okay, I think that's what we want. And then add or like odd equal, we're gonna launch expand zero, no, not 0, I, and if character I and e +1 are equal, so if s I equal to s I +1, wait, what if it did go outside of range? I don't. In the last loop. In the last loop, is it gonna go outside of range? Because we only check range here. So I guess I need to check range here too. So I can do the same thing. If I don't know why my microphone keep shutting down. It's like stop talking. Okay, so if we said if we need to check so like we don't get expand like outside of range here because we're gonna get to the last character at some point. Wait, maybe we can check if it is the last character and then we anyway maybe this is better. So if do we need to check range in the expand function? We are calling it with EI and we can check only in the even call. Because we're gonna move right, like imagine we are in the last character and we're gonna move right. We don't want to move right outside. Now this one is tricky because now I'm checking. I can send it to expand directly and expand will just not return nothing. But if you want to do it like this, we need to check for the E, is it last character? So I can do like maybe I equal length of S minus 1 and no, it should not be equal. Okay, what I'm trying to do here, I'm checking if I is it the last index, because if it was the last index I can't launch even, because in even I think I lost myself. Is it I plus? Yeah, I plus 1. Okay, I see it. Length of S. I plus 1. Wait, equal length of S, I guess. Oh, yeah, you're right. Less, because I wanted to enter the condition, you're right. So if I plus 1 is less than the last index, or like last, or like the range, or like if I plus 1 is inside the range, then if is I and is I plus 1, or like I plus 1 is equal, then we can launch expand. Then I'm gonna do E plus 1. Okay. Oh, I need to save it even. Now one thing here, I think I tested this before. I can access even. Okay, I don't know. Okay, let's see if it creates error and I come back to this. Now here we said if the length of odd is bigger than the result. So if the length of odd is bigger or greater than results. By the way, I don't have a result. So results, we need to save something inside it, and because let's say this character have no palindromic, the single character itself is palindromic. So B is palindromic, A is palindromic, B alone is palindromic. So at the first we're gonna have by default at least one palindromic, and we can choose, for example, the first character. So S0. Can you guys still hear him? Okay, what's happening here? Some people hear me, people don't. You need to check the even as well. Yeah, this one. I'm gonna check both. So I'm gonna check this one. You guys hear me good? Shadowbanks, do you hear me? Shadowbanks. So, if length of odd is bigger than the result and length of result, then we need to replace them, right? Because we are looking for a bigger one. So results gonna be equal to odd. Odd, which is the string we get from expand. Now in other case, if length of even is bigger than length of result, then it is the one that's gonna take over at the last. Result called even. Which while in the loop we do this. I guess I can put this. I don't know. So like there's something I forget. Is like now this variable I declare it in this loop. Is this accessible from this outside? Because what if I didn't do this? It wasn't. This kind of find error will be like I didn't find even, right? So maybe I put this inside here, or I declare one outside. I guess like this. So only when I get the even, then I check for it. If not, then I guess I will use this. And then return result after the loop finish. Okay, who is ready? I am ready. Who is ready? Oh, you scare me. Oh my god, my heart. Give me a warning before you do that. I was gonna disconnect. Okay, let's go. Okay, but we don't know. Let's submit. Ooh, okay. Nice, guys. I think the optimization is also did help. Thank you. And I'm gonna post the solution just in case someone wanna check it out. Where's Minatullah? Code. Give me code. Good job, guys. It was fun. If someone have a question, could you try using max? Oh, okay. I think max will be if we use max. So I create maybe here max of. Maybe I will keep it. It will be tricky because every time I choose it, I guess if I can put this outside, right? Wait, let me test this because I'm wondering if it's gonna work like this. Yeah, it's gonna give error if I put it because it's local variable. But I can put it all even here and just put it empty. So now it works. So I can do max here. So I can do like length max of even or odd. Wait, how you can do max?
Try giving it like even and odd and result, and the result would be equal to that. I'm not
Okay,
sure if that
but we're
works.
looking for a string that will compare just
Yes.
the length.
No, don't compare the length. Compare the strings themselves. So result equals max of result, even and odd.
Okay, so like I can do max and like string like this, test 2, test 3, like this, or I'm not getting it.
Try printing it instead, because
Max is, wait, why this one didn't work?
Print the output.
I guess you need to
I
print
didn't
it.
print it. Oh yeah.
Yeah.
You did say it and didn't catch it. Okay, test 3. Okay, that is really cool. I didn't know it. Nice. Wow, that's I think will I guess we just need to do max, even, odd, results. Wow, that's amazing. And then I will save it in the results. Okay, let's say run. Maybe I did some error. Wait, what did I remove? I removed this. Could slow down, so if you faster. Okay, max. So this max gonna return even or odd. Oh wait, did I remove even? No, it's still here. So why didn't it work here? Even odd result. It should work. The max of even or odd or result. Oh, because it may take the bigger one. No, what I'm saying. Why it didn't work? It's saying output expected to be. Why the output was B? Okay, let's compare it with the old code. So this is the old code. Run. Right, it accepted. Now we're gonna replace that line by this one. So I check if this length would max add up as a value. Will max add up a ASCII value? Really? So if I did A and I did C and I did D, yeah, it does take the, but is it gonna, if I did B? Oh yeah, wow, that's a nice catch. So it doesn't take the length, it actually takes the ASCII value. Wow, okay, that's amazing. I didn't know that. Thank you. Okay, that makes more sense. So I guess we still need to do length, but yeah, I guess it's not gonna work like this. Okay, that's cool. But I'm sure there is some way to like make this shorter. Okay, we're gonna stop here, guys. See you in the next week. If you wanna like host some PLD about LeetCode or about anything, you can just hit me in DMs. There's this document that have the upcoming LeetCode that we're gonna do. So we did the binary tree, we did unique paths. So we need to do account merge and the longest. No, I did this. We did this. So yeah, so we're gonna go through the week 11 and the week 12, where we're gonna have like more hardcore LeetCode. Okay, just hit me. Even if you wanna do some LeetCode, it's not in the list, hit me up. Can you paste the link? Okay, the link of what? The LeetCode? LeetCode is here and the Google Doc is above. Wait, this was an amazing interactive session. Okay, thank you, Sabah. Your explanation too was amazing. I still need to redo that LeetCode because I understand it, but I need to see it in practice. I wanna like do it with my hand and my leg. Okay, see you guys next week, inshallah. Good night. Good night.